In order to multiply 22 by 51 using the Egyptian system, we first indicate 51 as 5 heel bones and a slash. And of course I assume that you're familiar with the meanings of these symbols. The heel bone is 10, the slash is 1, the scroll is 100, the lotus flower is 1,000, and there are a couple of other symbols that the Egyptians used. Now, if we double this 51, and the reasons for this will become apparent in a minute, if we double the 51, we're going to have 2 sticks and 10 heel bones. Now we know that 10 heel bones is the same as 1 scroll, so instead of 10 heel bones we write a scroll. Then we double this number, and we get 4 times 51 essentially. Okay, we double the 2 sticks and we get 4 sticks. We double the 1 scroll and we get 2 scrolls. Then we double that, and now we know that we have 8 of these, so we have 8 sticks and 4 scrolls. Doubling this, well, let's see what's going to happen. We have 4 scrolls, that's going to give us 8. If we double 8 sticks, that's going to give us 16 sticks, which is 10 sticks and 6. So that we take, we could double this. We could mark down the 16 sticks, and we could circle 10 of them and cross them out and replace them with a heel bone if we wanted to do. Then we know that 22 can be obtained by adding 16. We need 16 to make up 22. We don't need 8, but we need 4. That'll make up 20. And then we add 2, and that's 22. So that we add the 16 and the 4 and the 2. Of course, the Egyptians didn't think 16 and 4 and 2. They actually used their own symbols to stand for these numbers. But they broke down the 22 in that manner and saw that they had to add this number and this number and this number. And you should think through how they might have thought about this. Okay, well, if we add these numbers, that means we got 2 of these and 4 of these. We write those down, we'll have 6, and then we add the 6 here, and that'll give us 12 sticks. Now we can circle 10 of those sticks and change them into a heel bone. So we got 2 sticks and a heel bone left over. Now, we add up heel bones. We got 1 heel bone here, and we got the extra heel bone that we had from the 10 sticks that we didn't want to write down here. And then what do we have? Well, let's see. We've got a scroll, and we got a couple more scrolls, and a bunch more scrolls. We write all those down. It turns out that we've got what we would call 11 scrolls. The Egyptians would have seen, well, I've got enough of those to circle 10 of them. To match them up with their fingers or whatever. And of course they have more sophisticated ways of doing things. This is a pretty sophisticated system, really. And we see that what we have, see, I've written down 2 scrolls and a lotus flower. I think I've only got 11 scrolls here. I don't have any heel bones adding up to scrolls. So I think I've actually kind of made a mistake here. I think maybe one of these scrolls shouldn't be there, so let me exit out. You can check me on that. But if I add the scrolls up, I get 11. 10 of them change into a lotus flower, and I'm left with 1. Now you should see the similarities between this and the system that we use. This will give you a deeper understanding of what we do when we multiply. It'll give you a deeper understanding of our number system. It'll also give you some clue about first of all, how smart the Egyptians were to think of this, because this was a step way ahead of any other system that was in use at the time. Second, the fact that they were somewhat limited. This system isn't quite as convenient as our system. That might lead you to reflect on what the shortcomings of our ways of thinking are. There certainly are some. We don't know if we've got the optimal system for representing mathematics or not, because we don't know what the alternatives might be. We don't know what the next step might be. So we can put ourselves in the position of an Egyptian with this system, and then we can look at our system and see its superiority. I doubt that any of us are going to figure out a better system, but somebody might.